Hey guys, before this video starts, I just want to let you know that this video is not new. I'm redoing it because after watching the subpanel teardown video, I realized that I screwed up during editing it. Also, some of the clips weren't quite as good as they probably could have been, so I'm going to re-upload it, and it's hopefully going to be a lot better. Hope you did enjoy, and I'll see you in the next one. I'm the Cyborg Sheep, and welcome to the Weekend Post. In this episode, we're going to be taking a look at this thing right here. Now, most electricians will know what this is. However, on my channel, there's not many electricians. And most of you are going, what the heck is this thing? Some of you might know these to be familiar. However, what this is a subpanel. I figured I'd go out and, I came riding by this house. It was all, under construction. It had all the scaffolding up. And on the boulevard, there was, like, a bunch of stuff. And I found this. Definitely worth having. This right here can take a maximum breaker size of 60 amps. So, in your main breaker, I'll do a picture of it actually. So when it comes to wiring in your subpanel, the complete current path basically goes like this. The power, at least on the consumer's end, starts off as 3 wires coming straight out of the transformer, in which the power originated from an 8 kV supply. 8 kV, of course, being 8,000 volts. 2 of these 3 wires will be encased in a black sheath, and both of them will be hot at 120 volts. The 2 wires will always be opposing to each other in the AC waveform, so such that is that if you connect across one leg to the other leg, you will get 240 volts. And the current, basically as much as she'll suffer. With the electricity in its current form, you can technically hook up any 120 or 240 volt appliance. Simply by connecting across a 120 volt lead and neutral, you can power a 120 volt appliance, or like I've previously stated, if you connect across the 2 120 volt leads, you can hook up a 240 volt appliance. But, like I said, this is technically speaking. Electricity is never perfect, and Chinesium does happen. Not to mention, of course, the goofs, what stick knives and paper clips in sockets, and also, power companies gotta get their pound of flesh out of you somehow. So, of course, to address those issues, your electricity goes through lots of stuff before it gets to your appliance, after coming out of the transformer. So the first thing it goes through, as many of you will know, is the electric meter. Now, most are rated to 200 amps. We'll go in there and say that's M. There we go. After the power that you're using is metered, it's then sent to an electrical panel. Like so. Alright, after the electricity comes into the panel, it goes through the first line of defense, the main breaker. A standard household electrical panel will be rated at 100 amps. However, if you need more electricity, you can always get the upgrade to a 200 amp panel. Now once again, technically speaking, you can, just like previously stated, connect across the 2 bars to get 240 volts, or 1 bar in neutral to get 120 volts. However, we still want to address the issue of overload, short circuits, and, of course, the goofs. So in order to do that, anything that you connect up to this circuit breaker panel will always go through a lower rated current for a breaker before it goes to your appliance. In this case, for the subpanel, it will go through a 60 amp breaker. Now, another thing to address is ground. So basically, the first thing that is grounded is the meter. What they do is they take a copper electrode and they just drive it into the ground. So we'll just say take out a wire and we'll do the symbol for ground like so. Now I'm not entirely sure how the main breaker panel is grounded, but from what I've seen, it's usually a thick bare copper wire that goes to a water pipe. But at this point, we can now finally hook up our sub panel safely and accurately, simply by taking out 2 of the hot wires from the 60 amp breaker, a neutral wire from the combined neutral and ground bar, and of course the ground. You can then wire in your sub panel to the main circuit breaker simply by putting the 2 black wires on the 2 bus bars, and neutral on a bus bar as well as ground on a bus bar. These 2 will be separate. So let's start taking out these screws. The first 2 screws that you see there are actually combination screws. You can turn them with either flathead or Robertson. Alright, sorry about that. My phone was running out of space. Really sucks. I really want to get to using this more. However, its limited space is kind of crappy. Guess we'll just have to use the camera for now. Clearly this was wired by an electrician because of the way it's wired. The wires will come and they'll go pull them straight to the wall, and then they'll send them wherever they need to go. And that makes it look relatively clean inside. So, I guess let's see if we can't get one of these out. Take a closer look at them. Okay, let's see here. Tell you what, I'll actually see if I can't get out the wires. Oh, there we go. There's one. Nope. Well, I mean, at the very least. There we go. So, here's a circuit breaker. As you can see, this one is actually an interesting way to do it. This one right here, this is where your power goes in. So, then it'll come out here. However, it will be limited by the circuitry inside this circuit breaker. Now, I don't know if I can get this open. The thing is that the way this is built is these are just staked closed, so I don't know if there's really any way of getting these out. However, let's try another stab at getting these out. Alright, I was able to get all the screws out, so just taking these out, and there we go. Now you can see how this should work. The teeth that will be powered at 120 volts for each leg. So, how this will work is, you can see that there's a bar going across here, and I don't know if you can see in that gap there, but there is another bar that goes straight along here, and each of these will alternate. So there'll be one that's on one phase, one that's on the other phase, and then it'll alternate through the 6 that you can put on here. So you could have 3 with 240 volts or 6 with 120 volts. Right here, this is the neutral bar, and this is the ground bar. However, if you take a look, and at least if I look, ground and neutral, there's no physical connection. This will actually be isolated because it's connected to the plastic body, and then this is directly on here, just to collect any, say this gets struck by lightning, this will actually be connected straight into the ground, so any charge that's on here will be bleed it off into the ground, and hopefully you won't shock this to get 2,000 volts right into you. Between these two, these are our two power inputs. So it'll come through this massive wire right here, and this will be one hot leg, this will be the other hot leg, and then this will be the neutral connecting straight into the neutral bar. So there you go. I'll just keep taking this apart. Alright, so there we go. Basically completely taken apart. So, there you go. That's pretty neat. Alright guys, so there you have it. I have a ton of projects that I would use this for. Unfortunately, I do not have the qualification, so sadly, I may never get to those projects. However, they will be replaced with something equally awesome, and those I will hopefully be able to do. So yeah. So that's how I tore down a subpanel. I hope you dudes enjoyed. Consider subscribing. Maybe like the video. And I'll see you dudes in the next episode.